Okay, what's up and welcome back to the channel. This is the Prokon Geek, and in today's video we're going to be looking at part 3 of Let's Design a Double Story Building Together. I think we already have part 1 and 2 out, so this is part 3. So without wasting too much time, let's get right into the video. Okay, so yes, this is part 3. And in part 1, we were looking at the building. We were just looking at everything. And I remember it was Christmas Day. So yes, today is no longer Christmas Day. But we did part 1 and we also did part 2. So part 2, what we had done is we established the layout. So part 1 was me basically cleaning the drawing and just describing to you how the loads are going to be moving from the roof going to all the way to the bases, which I think everybody managed to understand. Then part 2 involved us establishing the foundation, the structural layouts. The structural layouts, as you can see there, where we looked at the foundation layout, the first floor layout, and the eaves layout. And then we decided to leave out the ground floor because the ground floor is not something that's really structural. This is something the contractor can just do for themselves. It's not something that we have to worry about. And then I left at the end of that video, I told you we need to establish the tributary layouts in the very next video, and that is what we need to do. But remember, it's not just the tributary layouts. Remember, we had also not sized our slabs and our beams, or we had not checked them in terms of deflection. We're not sure if the deflection checks are okay when it comes to the preliminary sizing that we did for our beams. We remember we have 450D beams, 690D beams, then we have a 230 slab, that is the main slab, and then we have a canopy slab that is going to be 180 millimeters thick. But I was saying this will probably work given experience and everything. But then also I did admit I am a bit rusty, so everything has to be taken with a grain of salt and verified, as we were definitely verified. So what we're going to do is we're definitely going to need to check the deflection or the sizes of these beams and the slab in the next video. I think let's just do that in the next video. We will do it before we actually do the takedowns. By the takedowns, I mean just opening Excel file where we put the figures and then we actually calculate the load that is going down to the bases. But whilst we are on that, so this is the 2-minute mark, so we just call this the introduction. When it comes to the design of your buildings or your load takedowns, the good thing that you need to know is there are 2 methods that you can do. So the first method, where you do your tributary layouts or your tributary, what do they call them, your tributary areas, and then you find out what loads are going to your bases. That is what you normally have to do, because you want to see the load that is going all the way down to the foundation, because this will help you to establish what type of foundation that you need to use, and also to check if the bearing pressure of the soil will be enough to cater for the loads that are coming down. This is the difference between your strip footing, your pad footing, your raft footing, and also using piles. So that is why we do the preliminary distribution or the preliminary tributary areas that we use for the distribution of the loads to the foundation. If you really want a more in-depth video, I did this for the very first building that we ever designed on this channel. Remember how to design a double story building? We actually talked about that. We did the takedowns. I even shared the Excel sheets with you. So if you want that video, please check the link in the description box below. It is everything, and that video will go in depth about what I am trying to explain over here. But at the same time, that method, as I've seen other people were saying, yo dude, doesn't this take into account a lot of loads, and isn't this a bit of a slight over design? Aren't you taking into account too many things? Well, for the preliminary sizing, it does take into account a little bit of things, because if it is, what do you call this? It's preliminary. It's the first thing. You have to assume a bit of things. That is what design is all about. It's trial and error. But at the first step, you have to do a preliminary design, which is to take into account some worst case scenarios and some contingencies, right? For you to size your foundation and to see what loads will likely be going to your foundation. You just deal with the worst case possible. And normally it doesn't exceed 10% of the actual value, so you are not really on an over design schedule. And also you have to remember, if you're dealing with smaller projects, the over design factor is not that huge. What I'm trying to say is 50 millimeters of concrete on a small project will not save you a lot of money as compared to 50 millimeters of concrete. For example, when you're doing a stadium for the World Cup, 50 millimeters of concrete could escalate to something around 500,000 US dollars. So that is something, that's why it becomes key for you to single down or to manage your numbers as the bigger the project gets, and for you to use less conservative methods of design. But for this one, we have a fairly small building, and remember the guy already designed this already, so we're just trying to do the design or just show you the thought process that goes into designing this whole building. But at the same time, I just wanted to say, yes, we've talked about this, so this is a 5-minute mark. We're going to leave another chapter in the description to see what we're talking about. Now that we've gotten that out of the picture, what we're going to be doing today is establishing the preliminary tributary areas. But as I was saying, when it comes to the design that we're actually going to do, we're actually going to use the method where we're going to start designing the bases. Then the other method, what we're going to do is we're actually going to start designing from the top, that is to say from the eaves beams. That is to say we're going to look at the load that is coming from the parapet walls and the roof and goes to the eaves beams. Then we design the eaves beams. Once we get the reaction for the eaves beams, that is the load that will be going to the columns, right? And so we will definitely design for the, and then we design the first part of that column for that specific load that is coming from the roof and the eaves and everything that is going to be on top. And then once we are done at this portion, we're going to look at the slabs, design for the slabs, and then for the slab we look at the load that is going to the beams from the slab. Then we design the beams that are going to be on the first floor. After we do that, we are then going to look at the reaction that are going to be on the beams, and those reactions are going to be the loads that are going to be going into the second part of the column. So remember, the reaction or the design, the actual load that is going to be in the column, the first part, and the reaction from the beams at the second floor, at the first floor, is going to be the ultimate reaction of the load that is going to be going into the second part of the column, and that is what we're going to use to design. And then that load is then going to be carried down, including the self weight of all these columns, down to the foundation. That is what we're going to use as the actual loading that is going down to the foundation. And remember, we don't have a ground slab or ground beams, so what it just means is we don't have any load coming there. This ground slab or the ground slab in per se is going to be bearing on the soil. This is where my mouse is, so that one is not going to be transmitting its loads to the bases for this. And remember, we're using bases because the client specified they wanted a frame structure in case they want to expand, they want to join this to another building, they want to build to the side, so they want a standalone frame structure that will not result in them having to dig or remove walls or trying to upgrade from strip footing to a pad footing. So this client was building with the future in mind. They know they might want to expand, and that is why, as well, as you see from the side, mostly there are no windows there. They just say, you know what, we might want to remove the wall and just expand. So that is it. Now that we have this covered, 8 minutes, we've taken a lot of time. Now let's dive right into the video. And remember, the video today, what we need to establish are the grid lines. Remember, we had not established our grid lines, and then we need to establish our, what do you call them, our tributary areas. So without wasting too much time, now we're at the 8-minute mark, let's get started. So now that we have talked about everything, the first thing we need to establish grid lines. So if you want to reference, I've shared this drawing, obviously not with everything that's there, the nodes, the detail circles. These are premium things. As I told you, you actually need to pay, not from me, but I'm just saying on the internet you pay for such type of material. So it takes a lot of time to do this, but hey, who knows, I'm going to do a giveaway. But then the drawing, that is to say there's architecturals, including the double story layouts, but I think I gave you the foundation layout, which is the most important thing after all, is there for free in the description box below. What we're going to do is we need to establish these are the grid lines. Remember, the A system is going to be at the top, and then we're going to have 1, 2, 3. If you want where you can reference that, remember we have the detailing manual for concrete. This is the iStruct manual, the iStruct. This is the best engineering society, structural engineering society on the planet. So the first thing that we need to do is let's just establish our grid lines for everything. So we have the foundation. This is where we need to establish. So the first thing that I'm going to do is just going to grab the center of C1. Then I'm going to create a line. Let's make sure this is auto. Now that is auto, let's just copy it as well. Remember, my scroll button is not working, so that is something that we need to address as well. Alright, so we have those lines, so we're good to go. Then what are we going to do? Let's just create a line at the bottom, such as I've done. Then let's just extend EX. Let's extend this and let's extend that. And then we're going to, this didn't work, so we're just going to repeat EX, and then that's okay. Then we're going to match properties. Let's not match properties yet. Let's get another line. Let's go to the center of this, and once we grab to the center, since we're on auto, that is great, that is okay. Then what we need to do is we need to copy as well. So we need to bring it from the center of that, and then we need to get to the center of this, and I think we're good to go. And remember, we positioned these columns at the center, so that is where we're going to have. So now that we have something like this, we also need to drop another line, possibly from this point to this point. Then we need to EX. Now that we have EX'd, and also remember, if this is your first time to the channel, please just subscribe and like. Thank you very much. We had 2,000 subscribers. I could not be more than grateful, man. This is great. So MA, then we change the properties of this to match the other grid lines. All right, now we're good. Now we can remove those two lines. Now that is done, I think we may need to just trim this at this point, now that we have established that. So today I'm a little bit cool, and then we just remove this and we're good to go. Then we need to copy the circles. So what we're going to do is go to the reference, and let me do 5,000. Hopefully they are 5,000 and 5,000. We just copy this at this point, and let's drag it down to where we have. So remember, we don't have my scroll button on my mouse is dead, so I just need to copy. That's why I'm zooming in and zooming out. Then we need to change this to B instead of A. Alright, so that changes to caps and then B. Alright, and maybe we might just need to shorten this a little bit. Alright, so select there and then you trim. But the first thing, before we actually trim, let's move this from this point. Let's move to this point, and then let's select this and then trim. So what we're going to trim is trim everything that's from the top. And there we go. Now that looks great. Now that we have trimmed that, the next thing that we definitely need to do is let's just trim it by this point, and trim, select this line, and there we go, as fast as you can. Alright, then you go and copy another circle, go back. This time we need one, so copy, and let's bring it down to that point. And let's just copy it and bring it down to all the other points. So we're just gonna copy it, and there you go. You're gonna copy it and you're gonna bring it down to this point and that point. Hopefully my audio will be audible, and we're not going to have too much problems with my audio, because the audio has been an issue because of the fact that I've been moving around a lot and I'm no longer in the perfect studio. So now that we have this, and let's just drop it down to this point. Let's trim. Let's trim at this point. Let's trim at this point. That's great. So remember to like and subscribe and share the videos. Now that we have established the grid lines, the next thing that we need to do is we just need to, so normally on site, what you need to do is you need to agree with the architect about which points are going to be the grid lines. So we're just going to copy. Let's copy from the corner of this, and we need to copy it to the corner of that, so that it's the same throughout. It's the same throughout. Alright, that looks great. And then we're also going to copy it to this point. Alright, so that we have nice reference points. Now that we've established our grid lines, this is the 13-minute mark. What we're going to need to do now is let's move on to creating our tributary areas. So let's just transition into that. Alright, so once we have transitioned into that, hopefully I'm editing this video, because if I don't edit it, then the transition is just going to look weird. I'm just going to copy this to this point, and what I'm going to do is, well, I'm just going to copy from the corner there to this point. Alright, that's snapped to the right point. We're going to deal with the one that's in the middle, because we might need to just have different tributary areas for different reasons. What I'm going to do first thing, let me just clean up, because we now need to establish our tributary points. Yes, we know that. The reason why we are just going to have to clean up this is we can reference with everything else that's to the sides. Alright, for now, let's just remove all those dimensions. Let's just remove all the dimensions and all the text. Alright, so we're good. Now that we have done this, the next thing that we need to do for any column, this is what you do now when you're establishing the tributary areas that you need for, what do you call this, for your columns. Because remember, I think we should have kept C1 and C2, but I think you know. So we already know these are our columns. 1 2 3 4 5 6. So that is where ultimately the load is going to be going. So the best thing that you want to do is you just want the area that is going to be contributing all its loads down to this point and all its loads down to this point. And the reason why we're using the first floor layout is because check is very similar. The first floor is similar to the second floor, the ground floor. The first floor is very similar to the first floor and the ground floor are very similar. Actually, they're identical. The only difference is the wall, the arrangement of the walls. And if you check, you do have a canopy at that point and that point. And the only difference is instead of a slab, you have a roof. That just means it's going to be actually lighter, but at the same time, you're going to have extended walls above. But that's the same. On the first floor, you're going to have walls distributing the loads to the slab, or should we say the beam. Just depends if you're going to take it monolithically. So it's the slab slash beam where the walls will be distributing their loads. So the same that happens at the parapet or the eaves level. The parapet walls distribute the loads to the eaves, and then that is then distributed to the columns, and that is taken to the second part of the column. And at the ground and at the first floor, we have the slab and the beams distributing to the columns, and that is then taken to all the way to the foundation. So essentially, that is where your loads are going to be coming from. So walls onto beams and beams onto columns. Same here. It's actually roof and walls onto eaves beams, and then those beams onto columns. At the first floor, it's essentially walls and slab onto beams, and then those beams onto columns, and then everything from the columns down to the foundation. So that is cool. So as I'm saying, that is why we are going to be using it, because it's essentially the same thing. You feel that is exactly what you're going to be doing. So to do that, what we need to do then is you go to the center of your support and you calculate the distance between the two centers of your support. So luckily, because we have grid lines and the grid lines are going from the middle of the support to the middle of the support, I'm just going to establish this line at the center, but it's not really at the center of, it's at the center, or it goes this distance. Okay, we just have a line from the center of this column to the center of this column. Now we need a line from the center of this to this, but in this direction. So what we're going to do is, remember, the grid lines as well is positioned in a position that will make it. So what are we going to do? Let me just do it from this point to that point, and let me snap to that point, and let me move it. Let me move this line. Let me move it somewhere there. That is okay. So where is the midpoint of this line? That is cool. So what you're going to do is you're going to go to the midpoint of this line. That is okay. And then you're going to go to this point. So let's remove this line and let's get this line and take it to this point. But what we need to do is we need to extend this to the grid lines. So the lines have to be connected to your grid lines. So now that we have done this, the next thing that we're also going to do is, remember, unfortunately, because we don't have a support there, it's a cantilever, we're just going to draw a line that goes all the way to this point. And the next thing that we need to do is, because the distance between 1 and 2 and 2 and 3 is identical, we can always just mirror this. So let's mirror this from the mid of that to that point. And do you want to copy? Yep. No. Okay, sorry. Let's repeat. Let's mirror. And you grab to this point, then you grab to this point, and then you click yes. And if you check, it's going straight or intersecting with the grid line, so it's good to go. Then the next thing that you definitely need to do, is you need to establish. So remember, since the distances are the same, let's just mirror this as well, from this point to that point, and you're good to go. No, do you want to erase? No, I don't want to erase the source object. Actually, I did erase the source object, so I need to mirror it again. Next time, you do not erase the source object. Yes, now that looks great. So once we have done this, this is where I want you to take it seriously. The next thing that I'm going to do is I'm going to create a rectangle from, let me just gauge from this point. Exactly, thank you to track. Once we have done this, I'm going to select hatch. I'm not going to pick I'm going to go to where it says select, and since, remember, I've drawn a rectangle, and voila, we have shaded this area. And then what we're going to do is we're going to say it's 40, then we're going to change it to inside 32, then we're going to change this to 50, the scale. So effectively, what I have done by doing this is I have established the tributary area, or to say this is the area that is going to be distributing all of its loads to this specific column. And watch as I do the next. I'm going to create another rectangle as well. I know right now it might be confusing. You might not be able to see. I'm not sure what is happening exactly. Let me just repeat a rectangle. There, great. And pop. Then we're going to hatch, HA, and we're going to select the object. That is great. So this one we might change it from color 40 to color. I think the purple one is magenta. It's just, yep, that looks great. So this is going to be the tributary area for this second column. And then for the final column, what you're going to do is you still need to create a rectangle. So just snap to that point and then take it all the way to this point. And remember to hatch. Select the object, and there you go. So once that is done, let me see which color looks. That looks nice. Inside 32, and then you make it 50, and there you go. You have established the tributary areas that are going to be taking the loads. That is to say, from your roof and your first floor down to your columns. So remember, but the tricky thing is what we did is we have C3 and we have C4. So what just happens is that the tributary area, that is to say, for C3 and C4 is basically the same, because what we're going to do is we're going to come later on when we're doing our calculations. We're going to get this area that you see. What you do is you select the hatch, then you go to where it says area or cumulative area. This is the area that you're going to punch in. But remember, we are using millimeters. So when it comes to meters, you actually just have to divide that by 1,000,000. So that's 6993267 divided by 1,000,000. That gives you 6.9, which is almost 7 square meters. It's simple mathematics. 1,000 millimeters by 1,000. That gives you a million millimeters, right? 6 figures, 7 figures, yeah, 6 zeros. The dream figure for money if you want to be rich. So that's it. This is how you establish your tributary area. So these are the preliminary tributary areas that you're going to be using. So these are the areas that you have. What you have done after essentially doing that is you have established your tributary areas. So as I essentially showed you, it's just going to create a line between the two centers of your columns, as we did over there and there. Then after you do that, now we need to remove this these lines. We can always remove these lines if you want. Oh no, sorry. Although let me not remove the main lines. Let me just remove the squares. If you want, we just remove the squares. It's a way of creating lines between the centers of your two supports. Then once you create those two lines is when you then create your tributary areas, as I showed you when we were doing this. So that is basically how you create tributary areas. So just rewatch this video if you were left or you were lost. Anyway, just take time to revisit the video, see how I created the tributary areas. But it's as simple as that. And this is why a lot of people, as I was telling you, prefer to use lunchbox buildings, because with lunchboxes, as you can see, the tributary areas are quite easy and you don't have to worry yourself too much. So the principle is go to the center. What you do is create a line between the two centers of your support, and then you bisect at the center of that line that you've just created. And wherever the bisectors of the center lines, or for these lines that span from the center of one support to the other support meet, that is where you are able to get your tributary areas. So in this case, as you can see, because this one is only surrounded by one, or should I say two bisectors, this is the only area that it is fed with. But this one has this portion and this portion, that's why it's fed by a double portion. Same applies when it comes to this one. So this is why you have this portion and this portion. By rule of thumb, we're just going to say the corner columns will obviously have one area. The external columns, which are not specifically in the middle, will have two, as you have seen. But if it's a middle column, that is to say it is surrounded by continuity in all ends, because the reason is because this part of the column is continuous, but then the other side is discontinuous. There's no portion of the slab. That is why it's only given by two areas. So that is what you need to keep in mind. So thank you very much. Now I think we have seen how to create your tributary areas that will help you to size your foundations. This is what we're going to use to size our own foundations or get the laws that we go into the foundation. So I think we have an Excel file, and we've also opened up MathCAD. We have now installed MathCAD, because previously in the other video we did not have MathCAD. So we need to just check the deflection of the sizes that we did for slab and our beams, also do the takedowns. And then one thing that I need to update you on is my Prokon is still in demo. So for now, what I think we're going to do is we're just going to look at the layouts, establishing the structural layouts, and doing the preliminary calculations for the beams, the slabs, and everything else, but just to get the figures that we need to use for the design. But unfortunately, for the actual design, Prokon is still in demo. So I've reached out to them. They've offered me the student license, which is it's actually called the educational license, which is used by anyone who educates people or anyone who's still a student. So I'm not sure why it is expired, because I was given in October, but then this is just December and it's already expired. So I'm just going to reach out to them, either Janine, Michael, or Steven, ask them what we can do about it. And once they give me back, or they just renew, let me be humble. Once they renew, if they're willing to renew, then we continue. If not, we're going to have to look around. But in the same time, once we're done with the layouts and we want to find out the content, there's a slab that we designed for the how to design a double story building, which was in Sumo. We need to detail that one. And thanks to Jamie, Sima, and Paul, I think these guys are the most loyal subscribers to the channel. They're always asking me when we're going to do it, so I think that is what we would do first, detail the slab we designed in Sumo. But unfortunately, since it's in demo, we might just be able to see I'm not sure if I still have the file. We will see what we can do. But anyways, this is it for part 3. In the next video, we need to do our takedowns, and we also need to verify if the sizes we did for our beams and our slabs is okay. So until next time, please stay safe and don't sneeze. And remember, please subscribe, like, and share the video, and I'll see you next time.